So, in the last class we were discussing about the receiver operating characteristic curves, and also we mentioned the different ways you can draw the ROC curves, and ROC curves gives you what the information you are getting in one side false non-match rate, another side will be false match rate and corresponding threshold value, right. That is the idea. Now, that it is not necessary that you have to use in one side exactly value of FMR and exactly value of FNMR. What we do sometimes, depending upon the situation, based on the number of people or number of participants in the database, you may have to go for log function, so that it becomes better way to represent the data. Now, these ROC curves are useful not only to see that FAR and FRR, sometimes what we do, we use it to compare the two systems. Suppose you develop a system, and obviously to justify your system performance, you will be telling that my system has the accuracy of this, or you will be telling that FAR is this and corresponding FRR is this, right. Now, telling FAR and FRR, it varies upon different threshold value, that for a particular threshold value you will get one type of FAR and FRR, for different threshold you will be getting the different one, right. But your aim is to obtain such a threshold value for which you are achieving the minimum FAR and also moderately good FRR, or minimum FRR and moderately good FAR, because you cannot expect both of them will be minimum, as I mentioned in one class, that they are inversely related. Now, this will be used, can be used to compare the two matchers, but while you are comparing you should be careful, because it is not directly you can tell this matcher is better than the other one. I will come to that conclusion later on, but ROC curve tells you the trade-off relationship between FAR and FRR, right. As I told you that one is increasing, the graph is graph is like this, and this ROC curve tells you that it is a trade-off relationship between FMR and FNMR over a wide range of thresholds. So, if you fix a threshold, the corresponding value of these two will be known, or if you fix this one, the corresponding value of T and other part will be known, right. Now, suppose I have two matchers whose ROC curve is like this. Suppose this is B matcher and this is matcher A, right. So, you got the two ROC curve, one is for matcher B, another one is matcher A, and if I tell you that which matcher gives you the good results, obviously you will be telling this is giving you the better result, because that this matcher gives you that for any threshold value, this gives you that FMR or FNMR, one of them will be less than the other one, right. For this case, if I consider the same FNMR, then for matcher B, FMR is less, because this is the matcher B is FMR and this is the FMR for matcher A. So, straightway you can straightforward think that you will be telling the matcher B is better than matcher A, right. And you take for any operating point or any threshold value, or at any point, every point you will find that matcher B is better than matcher A, and you can draw the conclusion. Now, sometimes what happens that you can tell that my system is better than the other system at this operating point. At this point, if I consider that one is better than the other one, right, but for this diagram, of course, it is not the case. For this diagram, that always you will find that my thing is worse than the matcher B, right, and but you have to tell under what condition my thing is better than the other one, and that in that case you have to tell that if I consider that FMR is this, FNMR is this, then my thing is different. So you have to give the two variables value, that one is FMR, another one FNMR. If I consider that this is the case, then my thing is better than the other one. So, but as I told you that it is not really the true, that matcher you got ROC like that one is above the other one. This is not the case. You will find most of the case the diagram will be like this, right. So there will be intersecting at each point. So at this point, you know, both of them are having the accuracy will be the same, right. FMR equals to FMR of A matcher and FMR of B matcher, they are same. Similarly, FNMR of A matcher and FNMR of B matcher, they are same, right. And in that case, this point you may consider as for comparison purpose, that okay, but that time you will not get the good result because both of them are giving the same results, right. So drawing conclusion based on the intersection point will not be a correct method. Now suppose this is curve 1 and this is curve 2, and I decide that my FMR, that is false acceptance rate, has the higher priority than false rejection rate. False acceptance rate is because for some application false acceptance rate is having the higher priority than false rejection rate. In that case, the C2 will be better than C1, right. C2 will be better than C1, am I right? Because in that case false acceptance rate is higher than the, because I am keeping false rejection rate fixed, this is higher than this one. So you will be telling that C2 is better matcher. Am I right? Yes or no? Now, but if I feel that no, I want the false rejection rate has the higher priority than the false acceptance rate, then in this case what happens under this false acceptance rate, I am fixing it, you will find that this is higher than this of matcher. C2 is worse than matcher C1 because this false rejection rate is higher, right. So if it intersects, then you are in problem. Basically you will be asking to the service who wants the service, you will be asking which one you want. You want the false acceptance rate should have the higher priority or false rejection rate should have the higher priority. Based on that, you will be selecting that which curve is suitable for you, and you take the decision. And if it tells that no, I don't care, any one of them is okay or both of them are equally probable, then your problem is different, right. So that part we will discuss later on. But here at this stage, what we are telling, that false acceptance rate, if you give the higher priority, then the C2 is the better curve, and if you give the false rejection rate has the higher priority, then C1 is better curve, right. So in order to tell that which one is better here, in that case you have to tell the two parameters. One is, earlier days I was telling that no, only one parameter is sufficient, the other will come automatically. If I tell a false acceptance rate, corresponding value of false rejection rate you can obtain, and corresponding value of T is also known to you. But in this case, while you want to compare between the two methods, not only you have to tell the false acceptance rate, you have to tell what is false rejection rate also, right, because there are two matchers, you have to tell corresponding values so that you can justify which one. Even if you consider that my algorithm is good under this condition, means under this false acceptance rate and false rejection rate, this is the best performance I am getting. And you also will be telling that my algorithm will work very good under the false acceptance rate is this and false rejection. But how to compare this thing? It is a very difficult problem in that case, because you are getting only the two values, FAR and FRR of each matchers. Based on that, you will be drawing the conclusion. That is not possible. It is not, you will not understand what is going on, because they are two different parameters. So you have to bring them under the same parameter. Which parameter? If you assume that false acceptance rate is, let us make it fixed, and what is your false rejection rate and what is my false rejection rate, and then you compare, right? But and then you possibly you will be getting the good results under this fixed false acceptance rate. Unfortunately, your matcher algorithm is not good for that false acceptance rate. It is good for some other false rejection acceptance rate, right? So depending upon the, so this is not a good practice to go, or it is not a good way to compare the two matchers under the keeping one of them fixed, because your algorithm may not be good for that parameter, fixed parameters, may be good for some other parameters. So that is the thing what we want to tell here. So what is the way out? Way out is that, can I get that equal error rate? What does it mean? That equal error rate is nothing but under what condition both false acceptance rate and false rejection rate is same. So if I know one of them, FAR of A equals to F of A, F of R of FRR of A, and similarly FAR of B equals to FRRB. If I know this, then I ask what is your false acceptance rate and what is my false acceptance rate, because both of them same, then whichever is smaller, that will be the better matcher. Because now the say earlier degrees of freedom is too many, because I have only one information, false acceptance rate A and corresponding value of false rejection rate B, but A and B, these two are, this is not same, this is not same. By knowing one of them or two of them, you are not able to draw any conclusion which one is better. It is difficult. So what we are telling, no, let us make it fixed. But if I make fixed, you are facing another problem, because under that fixed FAR, my algorithm may not be giving you the good FRR. But for some other FAR, maybe my algorithm is better, but his algorithm is not better because of this scenario. So drawing conclusion is not possible, or it is not correct. What we are telling now, let us assume the condition where FAR and FRR are same, right? So my FAR and FRR is fixed, same, your thing is also same. Now which one is smaller? That is the better algorithm, right? So how to get that? This is nothing but a line you are drawing at 45 degree, right? Under this condition, you will find that FAR and FRR are same. Now smaller value of this is better than this, right? So you will be telling that this algorithm is better than this algorithm. Is it clear? So you get equal error rate. So you will be drawing a line here, and this is equal error rate for this too. And you will be telling that if you use the equal error rate for your algorithms, then matcher A is better than matcher B. Now again, if you see that single parameter FAR or EER is also not justifiable, right? Again, if you consider EER, there is also big problem, because you are drawing a conclusion, my matcher is not good or better than your matcher, because EER is different. Unfortunately, EER is the if you see the previous diagram, here gives you this one and this one, so very small difference is there. And this is such a small difference, but for that small difference you are penalizing one matcher, which is not correct. So what is your aim? Your aim should be that I have the two graph, one is genuine the genuine probability, another one is imposter probability density function, right? Your aim, I will be telling that my algorithm should be the better one if I can show that these two distributors are separated, widely separated. So this graph is here and this all imposter is in lower value and all genuine are far away from the imposter values. So the best possible case will be, right, this is imposter and this is genuine one, and I can have the threshold value like this. So all of them will be rejected here and all of them will be accepted here. That is the best. So how much they are separated, right? That separation value, if I use a parameter, that will be useful. That is known as the D prime. D prime is nothing but mu m minus mu n, mean of these two distributions, mu m minus mu n divided by sigma m square plus sigma n square, right? That means variance of this distribution and variance of this distribution, they are square root. If I divide it, then you can find out the D prime. So this D prime also can help you to determine how much it is separated, how much it is there. So larger value of D prime, better is your matcher. You can tell that yes, this will separate it out from the imposter with this value of D prime. Am I right? Yes. So, but here also you have some problem. Suppose you have mu m and mu n, they are equal, and sigma m square equals to sigma n square. This is for the matcher A. And in matcher B, mu m prime equals to mu n prime and sigma m prime square equals not equals to sigma n prime square, right? So both of them are having the same mean. This mean equals to imposter mean, mean of genuine equals to mean of imposter mean, and here the variance of sigma m and variance of m and variance of imposter, they are same, and here but it is not the case. In both the case D prime will be 0, right? What will be conclusion? You cannot draw any conclusion in that case. You will be telling both of them a lie, right? Yes or no? But you see the graph here, both of them are having the same mean, standard deviation is same, your diagram will be look like this. Same mean, but standard deviation is different, and this diagram may be like this: false acceptance rate versus false rejection rate. So you see that D prime gives you 0. So you are telling that both of them are alike, but in reality it is not. In reality, that for smaller value of FMR, false acceptance rate, the matcher B is giving good results. So anyway, this is matcher B and matcher A. So under this kind of conditions, even if you are telling that D prime is giving you the result, but you are not able to draw a conclusion at this stage, but here you are finding that no, matcher B is better than matcher A for small value of FMR, but and also for large value of FMR, matcher A is better than matcher B. So you observe here one thing, that both equal error rate and D prime are giving you the equal importance to FAR and FRR, and also equal importance on the cost. That what do you mean by cost? Cost means that making a false acceptance has some value, suppose in a nuclear plant I allow somebody falsely, it has tremendous effect, right, because then he may create a havoc in the nuclear plant. Or if I stop somebody to coming, entering, genuine person, I am stop entering genuine person in my lab several times, then next time he will not come. He will tell that every time he is throwing me out, why shall I go there? Inconvenience will be there. So this, if you give the equal weightage or equal cost on this event, that is also a big problem for us. So you should not give the equal weightage to false acceptance and false rejection, right. So if it is the case, then we can define that expected overall error rate by expected overall error rate at the threshold point t is equals to false acceptance rate at t into probability of imposter plus false rejection rate at t into probability of genuine user. What it means? P imposter is the probability that random user will be an imposter. That probability that a person has come, he is a random person, he is an imposter, that I can find out. And similarly, PG is the probability that a random user is a genuine user. So Pi plus PG must be equals to 1, right. So the false acceptance rate into the probability that a random user is an imposter plus false rejection rate at threshold t into probability that a random user is a genuine user, that will give you expected overall error rate at the threshold value t. Now your aim is to get such a t such that this is minimum, right. So you can draw now conclusion that if I know Pi and PG, I know both of them at different threshold value, I can find out what is the minimum value of ET. That is your minimum expected error rate, right. So this is basically you will be getting FMR T into Pi plus FNMR T into PG, that will give you a value K. So the K is a line, this is a line, right. So you will be looking for that line which touches that point, and this is your minimum expected error rate, right. So what I have considered now, I have one thing to remember, that I have considered Pi and PG. How to get this Pi and PG, right? That is a difficult problem, because in a lab you have to ask somebody to come, randomly he will come and either he will try act as a genuine user or act as an imposter. And if he has come in as an imposter, it should be matched with imposter, that he has been considered as a false acceptor. So you have to find out that distribution, you have to see, based on that you will be obtaining your Pi and PG. If I consider Pi equals to PG equals to 0.5, because sum of these two must be equals to 1, that is, it is nothing but you are giving the weightage of half to both the side, which is nothing but half of false acceptance and half of false rejection you are adding to get the accuracy. That means sum of two errors divided by 2 gives you the accuracy, and which is the normal practice, that you are giving equal importance to both of them. But as I told you, that is not a correct approach. Depending upon the application, you should decide what is the weightage to be given on false acceptance and on false rejection rate. Generally, this should not be equals to equal error rate. Now you observe that we can improve further if we introduce the term cost for false not match and cost for false match. See, every organization or every application, there is a cost for non-match, right. Say if I stop you while entering into my classroom and you are giving the data and every time I am rejecting you, so you will be waiting outside. By that process you will be losing 10 minutes, right. So that has a value, that cost is there. So the cost you can obtain. Similarly for this also, false match also there is a cost. This cost you multiply, then you will be getting the cost, and you can determine such a curve where it gives you the minimum cost. So under what value of t for given PG, PI, CFM and CFNM and FAR and FRR, you must be able to find a cost, right? That T is important now for you. Is it okay? Now how to get FAR and FRR? Because I told you PG, you are coming and I am testing randomly and I am finding PG and PI. That is possible. I know a priori the cost of FM and cost of FNM, right? This is also known to you, because I know that if somebody enters falsely, how much destroy he will be doing in my organization, that is known, right? Or if somebody does not come or he was not allowed to enter as a genuine person, then what is his wastage of time or cost? So this also can be estimated. But how to do this too? How to get these two? Any idea? This is possible to get, yes or no? This is possible to get, right? Because every organization has the value of assets. So that if somebody enters wrongly here to spoil, I know what is the cost of my building or this area, that is your cost, right? This is also known to you. How to get these two? Idea, is there any idea? Yes or no? See, you have designed a system, and obviously while designing a system you have tested it, right? And tested it against whom? Tested it against a set of people, set of subjects. Which subject? What type of subjects? The subject should be similar to the application. Suppose you are applying to the students, your database will be, test data also will be on students, because you should not use the test data from the villagers. You know that environment where you are going to use it, that test data you have, and under this test data what is FAR and FRR you have already obtained. That FAR and FRR will be used to determine your cost. Okay? Now once you have deployed that machine, now you are getting the genuine data, and now there you monitor how much false acceptance, how much false rejection rate at every instant of time. So correspondingly you upgrade it this one. So ultimately it will become a stable one. Yes or no? Is it clear? So initially you have the lab environment, based on that you determine what is your FAR and FRR, you deploy the system and keep monitor on the FAR and FRR part, correspondingly you upgrade your FAR and FRR, and then correspondingly you compute your cost. Now whatever we are doing, that FRR and FRR, but before that there are other issues which generally we don't care, but they matters. There are two types of errors still pending. One is failure to acquire. What it means? That you are a person and you do not have fingerprint, right? Or you do not have your eyes, or you do not have finger. There is no guarantee that you have to have the finger, except the face, everything is variable, right? Only face should exist, must exist. Other part, the finger may not be there. Suppose I take the point finger may not be there. Or the fingerprints are missing, that because of hard working this is gone, nothing is there, plain. So system will not be able to get any data from that, right? So this is one type of error, and this is not the small thing. In case of fingerprint, it is coming 15% of the rural people. The number is very high. Failure to enroll rate is also not a small number. This is, even though I have the fingerprint, even though I have the iris, I stand in front of camera, but I am not able to give you my iris data. Maybe because of my bad day to provide the biometrics data, right? I have the fingerprint, I am giving the full pressure on the scanner, but it is not giving me the results. So these are the two types of failure exist. In the Vendors, what they do, they subtract this thing from the calculation. They immediately, as soon as they find that quality, image quality is poor, they delete it from their test data. So obviously, their accuracy will be very high, right? Because they don't have the bad quality of data. All quality data is very good quality, and result is very good. So what you can study, the failure to enroll, not the failure to acquire. Failure to acquire, you cannot do anything because fingerprint does not exist. So for them, manual intervention or exception handling will be coming in between. But failure to enroll can be tested. What is the failure to enrollment rate? How can you obtain this? This can be done in the lab and moment test, right? How many, you call people from different zones or different characteristics holders and tell them to provide the data, they provide that, and based on that you can determine what is the failure to enrollment rate. Now, if you make the very tight failure to enrollment rate, any small problem you reject them, what is happening? Number of rejections will be more, and that means manual intervention will be more, right? And what happens in that case? The cost will be increased because manually you will be enrolling them, or you will be making that yes or no, he is the identify the person, or there is a chance of making mistakes will be more, or chance of coming through improper channel will be more, all those issues will be coming. So this failure to enrollment plays an important role, right, to create the trade-off relationship between the manual and automated system, right. If you make it very high failure to enrollment rate, in that case what will happen? That authentication will be very good results you will be getting, but manual intervention will be more, so cost will be more. And if it is a very small, the value is very small, then that there is a chance of poor authentication technique and manual cost will be less. So you have to decide what should be the appropriate value of FTE. For in the case of iris, what we observe that 0.5% data is, FT is very high, 0.5%. That means 0.005. That means, what is the 0.5 means what? 5 out of 1000, right? 5 out of 1000 people, they are not able to give the data. It's a big number. So for 1000 people, 5 people will be tested against through exception handling. Now, implication of error rates, that you have to understand carefully. Why does it reject me? That is one thing. The genuine person has come and say through verification mode, he has a smart card, he has given his biometric data and he has been rejected. And he feels very bad, right? Because I know that because you go to the bank and you have signed on your check and they are telling no, it is not your check or it is not your signature. You feel bad, right? It's me, I have given my signature and you are telling it is not my signature. So how this happens, you check. Fingerprint system has assumed the 3% false rejection rate. 3% is very nominal because it is much higher than. Let us assume the 3% false rejection rate in a fingerprint system, and 2000 people are served per hour. It's a very small number, 2000 people are coming, accessing the system per hour. There are 16 hours, 8 hours off, and then the number of people who will fail to be verified is 3% into 2000 into 16 hours, so 960. Is roughly 1000 people will be rejected, even though they are genuine, right? So and unfortunately, you are one of them, right? The next issue is coming. Why does it point it to me? This is another problem. You see the wish list area in the shopping mall. We have decided that there are 25 people whom I do not want to allow in my shopping mall, and assume a system, a face system which has 0.01% false positive, which is also very nominal in a face. database, phase system. Whistler database contains 25 pages and 500 people enters into the shopping mall, and out of this 500 people, because of 1%, 25 into 500 into 1% gives you 25 people. The 25 people will be accepted as a false accept, right? Will be accepted as a false acceptance. Unfortunately, you are also one of them. Even though you are a nice person, your name should not be in the database, but it is showing that you are in that database. So that is the error rate implications. In traditional thing, if you find that generally fingerprint has the false rejection rate 3 to 7%, after subtracting all these things, after subtracting FTA and FTE, false, right? That failure to acquire and failure to enrollment, after eliminating them, you will find that FRR is 3 to 7%, and for that corresponding FAR is 0.0001 to 0.01. Phase, you see the very large value 10 to 20%, and with FAR 0.1 to 1.0%, voice is 10 to 20%, with FAR is 2% to 5%, IDs is 2 to 10%, and it is more than 0.001% FAR, and hand is 1 to 2%, 1 to 2% also there, and signature is also very high false acceptance rate corresponding to others. Right? These are standard things, these are not, because we are also facing similar problem. Now, biometric mis and misrepresentation. This is one thing is important, or we should discuss that biometrics X is the best for all applications. See, any biometrics, one thing you remember, cannot consider it is best for all. You have to understand carefully the what application it is, what type of biometrics is suitable, because you know lot many information is required, because cost is involved, accuracy is involved, and all. Then type of system you are going to consider, these are involved, whether it is feasible to apply those systems are also important. So biometrics S is the best for all application is not the correct thing. It is dependent upon the application you have to decide. Biometric X is unique for each individual. This is also not correct. Remember one thing, that we can tell for this set of people, I am getting the data where fingerprints are unique or face is unique. Since I do not have the whole globe data, I cannot draw this type of conclusion, first part. Second part is that if it is unique, how come then error rate is 3%, 4%? That means there exist 3% people whose accuracy, are matched with other persons, right, because of some other reason. So you cannot tell that this is perfectly unique. It is expected that this is unique. A single number such as ER quantifies the system accuracy. As I told you that even though we use ER or the cost or the minimum error rate, expected error rate, but this will not give you the perfect feel about your system. You should tell more about it, that not only ER, other behavior of the curve, you should explain clearly. The biometric system is plug and play. It is not the case. Reason is that if it is a plug and play, then lot many problems could have been solved. Reason, first thing is that your system is dependent on the image or the image quality, how you are using them, and what part of this ROI you are extracting, all those things will be coming. Yes, scanner may extract the X, Y size of image. Another scanner is considering A, B size of image. Then how are you going to handshake them? Is there not that? So it's a plug and play is not the correct thing. It needs lot of manipulation to make it active. Real accuracy performance can be predicted. It is also not possible, because your test data is based on the laboratory environment, and laboratory environment the people gets enough time to give his data, and also I can ask him to provide the data several times. Based on that you consider the best one, but in the real field it is not the case. He gives the data and he is allowed to go, right? So this is not that accuracy you can predict correctly. However, that accuracy only we are taking into consideration for our calculations. Best FAR and FRR mean the most accurate system. That is also need not be, because of the application you have to decide what is the FAR and what is the best FRR. Multiple biometrics outperform the single biometrics. That is the thing what we want to encase. We are trying to do something that yes, multiple biometrics if we have, possibly error can be reduced, but cost will go up. This is another wrong thing, that decision threshold is not used in biometric system, because in the biometric system, since it is a pattern recognition system, you must use a threshold value. Based on the threshold value, you take the decision whether you are accepting or rejecting. So, this feature extractor can be used with any match engine. This is another wrong thing, because they are not, mostly they are not interoperable, right. So, if I have one system, can I use your feature extraction algorithm for my matching algorithm? It will find that it is giving you the different problem. It will extract some features, but your matcher will not, because you do not know what is the size of the feature vector, what are the type of materials are there in the feature vectors, you do not know. So, as a result you are facing problem. Large templates means better accuracy, need not be. It depends upon the how accurate template it is, how accurate feature vectors you have, that is the important thing, instead of the number of feature vectors, feature elements in the vector. Face recognition prevents terrorism. It is also, commonly we use the face recognition for terrorism, that I see the face and then we draw the conclusion, yes, he is the terrorist or not. But in reality, it is not possible, because we cover the mask, we use masks to cover our face, and as a result this is not possible. Then your database may not contain all the face data. As a result, the database is not a closed database, so you will not be able to do this one. Biometrics means 100% security, but how is it possible? FAR and FRR exist, they are not 0. If it is 0, then what you are telling is correct. So, this is not correct. Then it is a threat to privacy. This is a big problem, right. How can I give my biometrics data? How can you safeguard my biometrics data, right? Say, first thing is that you can encrypt. Second thing is that your feature vectors, right, if I by any means it has gone to somebody else, can he obtain a mask against your feature vectors, right. So, inverse exist or not, that is not known. Biometric sensors are unhygienic or otherwise harmful. Tell me, is it unhygienic? Do you expect that is hygienic, unhygienic? This may be unhygienic, you do not know, because you know what happens that once you go for the contact lens type thing, that where you have to touch the lens, right, then your predecessor, whoever has come to give you data, you do not know what type of hand he has put. He can put the potassium cyanide on the top of it, and you have taken that, you have given your fingerprint, and you are also carrying the potassium cyanide with you. So, it may be harmful, it may be unhygienic. So, it should be there, wherever the contact sensors you are using, you have to be very careful, you have to justify that it is safe, otherwise it may create a havoc in the society. Now, whatever we discussed till now, it was positive authentication. Now, the negative authentication. You have the null hypothesis. In the case of positive authentication, H0 was 2 sample match. Here it is a, I do not want that 2 samples should match, because it is a wish list case. So, null hypothesis is that the 2 hypotheses do not match, 2 samples do not match, or alternative one is that 2 samples match. So, there are 2 errors. In that case, false negative means the 2 persons, they are matched, they are supposed to be matched in reality, because same person has come to enter the shopping mall and he should have been matched with the database, but in practice it was not matched. It was shown that no, he is not the man within the database, right. So, that is your false negative. And this frequency of this type of error is called false negative rate, which is FNR. False positive is nothing but a subject who is not supposed to be matched with the database, and unfortunately he has been matched, false positive, right? And for this frequency it is known as false positive rate. So this is the diagram. So imposter is this side and genuine is this side PDF file, and as we discussed in the previous case, this is also same as it is. See, there are two types of error that a verification system can make, right? One is FIR and FRR, or false positive and false negative, and both of them have the different implications and against different class of people, right? Now, false accept in a secure system means an unauthorized person has been allowed, and that means a security breach, right? False accept in any secure system means that an unauthorized person has been allowed. What it indicates that there is a breach of security, while false reject is that an authorized person has been, he is a genuine person, you have stopped him to go there, and as a result his inconvenience has been increased. So here the implication is that breach of security, and in this case inconvenience or convenience problem. So the trade-off between FAR and FRR translates the trade-off between security and convenience, right? Now, by setting false acceptance rate 1, what is mean? It means that false rejection is 0. That means everybody will be allowed to enter. That means what? Security is chaos, right? And so it is a very insecure system. Everybody is allowed to enter, insecure system. And FRR is 1. False rejection rate is 1. Obviously, false acceptance also will be 0, right? False rejection is 1 means I am stopping everybody, and in that case convenience will be poor. Inconvenience is very high. So FRR and FRR inversely related, these are two also inversely related. If one is increasing, then the other is decreasing. Now, can I draw this statement? The convenience of the biometrics is nothing but the user friendliness. How much it is friendly with the user, how much I am allowing everybody to enter into the system easily. So one example is that face and voice, they are very easily available biometrics, through which is a very easy friendly environment through which anybody can enter, right? So obviously this will be more insecure system, but this is not the case with the fingerprint or IDs, where you are not allowing easily to enter into the system. Now, convenience of the particular implementation, here it is not the biometrics, it is how we are implementing the system. Now, in case of implementing the system, you have to see this part, that how you are handling the exception, because if you are making the secured system, lot many failure will be there, for genuine people will be rejected. So you have to do it manually, right? And if you increase that false, if you are increasing the lenient one, your lenient means that user friendly one, in that case what happens? That your monitoring system should be accurate, so that you have allowed so many false people into the system, they should not create any problem, right? So both of them are important parameters you have to understand carefully. So as I know that high false rate makes inconvenience to the legitimate users, so convenience is nothing but 1 minus false rejection rate. If false rejection rate is high, convenience is 0. If false rejection is less, friendliness is high, right? So higher the value of FRR, lesser the convenient, because more subjects are incorrectly identified and therefore subject or to denial of service or exception handling will be increasing. And if false acceptance rate, as I told that it is related with the security, if false acceptance is 0, then it is fully secure. If false acceptance rate is 1, then security is in problem, right. So, security and convenience are, there is a trade-off relation between these two because they are related with the FAR and FRR. So, this is an example that you have the ROC curve. So, that if I see the secure system, obviously this curve will give you the higher security, right. But if I see convenience one, then this will give you the better results, right. That measure A will be the better than measure B. Now, the question is coming, the cost versus security. So, there exists a relationship, trade-off relationship between security and cost, because as security is high, you have to pay more, right, because that manual intervention will be more, because security is high means what? False rejection rate is, you will be there, right. And what will happen in that case? You have to, manual intervention will be there, so you have to pay more. So, by setting false rejection rate is 0, false acceptance rate, we have the very cheap system, very insecure system. By setting FAR equals to 0, you are getting that anybody and who has to apply costly and human manual rev, right. There are lot many money, you have to, false acceptance you have very tight. So, too many people will be rejected. So, manual intervention will be there. So, cost will be involved there. So, cost is related with the false rejection rate, because as you are increasing the false rejection rate, they are genuine persons, they will come for proving themselves that yes, we are genuine persons. So, you have to collect their data manually and verify them. So, cost will be increased. So, cost is directly related with false rejection rate, but security is 1 minus FAR, right, as we have already discussed, right. Security is highly related with the cost, because as earlier convenience was inversely related with the security. Now, we are telling that no, security is related with cost. This I have already discussed. You can, so this is the discussion on that. So, note that you can assume that whatever we have obtained, that we are not considering FTA or FTE, right. So, that is basically big problem. FTE and FTA must be included in computing your security, and because they are involved, they are also, see, I could not enroll them because of their poor quality of image or because of some other reasons, but they are also in my database. They will come with their informations and you have to allow them. So, there exists certain hidden cost which we are not considering, right, in computing, because computing our convenience or the security, I have used only FAR and FRR. But what about the case of FTA and FTA? So, FTE and FTA, their value should be added to determine to the convenience factor or the cost factor, because they are also involved of that manual intervention, exception handling will be coming in between. So, in the case of negative authentication, security will be the just reverse of it, is 1 minus FNR, that lower the chances of missing undesirable subject, the higher the security. And convenience is equals cost of false positive, right. If false positive is there, then obviously that innocent people will be troubled, because they will be asked to stand up in a queue and interrogation will be there by police or by somebody else, that how, because they are the enlisted in the database, right. So, false positive will increase the cost and security is 1 minus FNR. So, when if false positive and false negative rate is too high, system becomes inconvenient to all. And in the case of positive authentication, FAR is the security problem, while FRR is the convenient problem for the negative, while for negative authentication, FNR is the security problem and FPR is the convenient problem. If you see the diagram, I think there is still more. So, what I am telling that this FA, false acceptance and false negative, they are the security problem, and false rejection for the positive authentication and false positive for the negative authentication, they are the convenience problem, right. So, this is your for security, and this is for your convenience. Positive authentications, security is FA and convenience is FR. For negative authentication, false positive is the convenience, and false rejection is also convenience for the positive one, right. Similarly, if I see the diagram, that itself we can. So, in the case of false match, it is false acceptance and false positive, they are giving you the false match, and false not match is false rejection rate in the case of positive authentication and false negative in the case of negative authentications. Right. This diagram will explain everything whatever I discussed till now.